The unique profile of Simponi can be attributed to an innovative design process. Simponi was developed using the newest state-of-the-art transgene technology, which builds on over 25 years of experience in therapeutic antibody development. Transgene technology is based on genetically engineered mice carrying human antibody genes. In the development of Simponi, these transgenic mice were injected with human TNF-alpha to trigger an immune response, resulting in the production of high-affinity, fully human antibodies which bind and neutralize human TNF-alpha. Simponi was selected from a range of antibodies produced in this way based on its high affinity for TNF-alpha and potent neutralizing properties, which are favorable for a long dosing interval, alongside the other beneficial pharmacological and physical properties. Unlike antibodies generated by other methodologies, Simponi required no further modifications to its protein sequence to improve its affinity before it could be used in humans. Therefore, there was a reduced risk of golimumab losing its beneficial properties during development. A feature common among antibodies produced by transgene technology is their very high affinity for the target antigen. Transgene technology exploits a natural process that occurs within the immune system, known as in vivo affinity maturation, which is responsible for optimizing the affinity of antibodies produced during the immune response. During in vivo affinity maturation, B cells inside the mouse lymph nodes undergo several rounds of hypermutation and proliferation, and are selected for continued development after each round based on the affinity of their surface antibodies. With each generation of B cells carrying antibodies with higher affinity than the one before, B cells that survive this process of natural selection carry genes for the highest affinity antibodies. In a multi-step process involving the formation and selection of hybridomas, genes from the best antibody can be cloned and transferred into a fast-growing cell line, allowing the antibody to be produced on an industrial scale within a bioreactor. This process gives patients access to therapeutic quantities of fully human, high-affinity antibodies, which have been selected for their optimal physical and pharmacological properties.